In this video, we're going to have a look at differentiation of inverse trigonometric functions. So let's have a look at where they come from. This is all given to you in the tables, so you don't have to remember these. And they're all so similar, you will want to look them up rather than thinking that you know them. So let's have a look at one of these now. They all kind of work the same way if you want to prove them. So let's have a look at the inverse sine of x over a. So that means that the sine of y is going to be equal to x over a. So if I create a little triangle here, here's my angle y, and we have my sine is equal to opposite I over hypotenuse, so that's x over a. So what would this side down here be? And based on your knowledge of Pythagoras, this is going to be the square root of a squared minus x squared. You can see this a squared minus x squared in here, and in here, and here it's a squared plus x squared because we're looking at tan. So the x and the a will be on the straight sides if we drew this triangle. So let's look at trying to get dy dx here. So we have a sine y is equal to x. So we could differentiate both sides with respect to y. So dx, instead of having y equals and doing dy dx, we have x equals, we're going to do dx dy. So sine goes to cos. So you're going to have dx dy is equal to a cos y. And if dx dy is equal to a cos y, dy dx, if we invert it, this is over 1. Dy dx is equal to 1 over a cos y. And let's look up here. What is the cos of y equal to? The cos of y is equal to a over h, which is the square root of a squared minus x squared over a. So if I put that in down here, I'm going to get dy dx is equal to 1 over a times the square root of a squared minus x squared over a, and these a's will cancel if we divide by a. So dy dx is equal to 1 over the square root of a squared minus x squared. And similarly, we'd get minus if we did the sine one. Sorry, if we did the cos one, and we get this one if we did tan. So they all work out the same way. So maybe practice those other two, these proofs of these inverse trigonometric functions. Hasn't been asked at leaving cert, but that's not to say it won't be. So let's have a look at a couple of questions in relation to this. Let's look at some questions in relation to the domain here. We're told that y is equal to the inverse sine of x. So that means that the sine of y is equal to x. Now, we know the max and min here. The max is 1 and the min is minus 1 for any sine function. So that means that we could put x in the middle here like this. But because sine y is equal to x, we could say 1 less than or equal to the sine of y, less than or equal to, minus 1, and less than or equal to 1. So the domain of this function has to be from minus 1 to 1, and we write the domain in these square brackets. We look at the second one here, we can say the sine of y is equal to x plus 2. So again, we're going to have this as our x plus 2 in the middle. The max and min value of this is from minus 1 to 1, and we just take 2 away from each of them here. And we're going to get minus 3 less than or equal to x less than or equal to 1. So the domain here is from, that's a minus 1, minus 3 to minus 1. Similarly, we can say the sine of y is equal to 3x minus 2. So we're going to have that 3x minus 2 in the middle of our domain. Our max and min, again, don't forget your signs like I do sometimes. So we add 2 and then divide by 3, and you can do it. And there's a couple of other ways to do this. You could separate them into two parts if you wanted. So if we add 2, we're going to get 1 less than or equal to 3x less than or equal to 3. And if we divide by 3, we're going to get a third less than or equal to x less than or equal to 1. So the domain of this one is from a third to 1. So nice easy domain questions. Sometimes the way they're asked, if you haven't seen these questions, it's kind of can be confusing, but just practice a couple more of these and it should be easy enough. So we look at this example with an x squared on the bottom. It may be easier to use the chain rule here. So let me have a look at using the chain rule to see does this work for us. So what we want to do is we want to let y equal the inverse sine of v. So therefore v is equal to 1 over x squared. Now the chain rule, we can get dy dv, and we can get, with this one, we can get dv dx. And if you look here, dy dv times dv dx, the dv's will cancel, is equal to dy dx. I don't normally use this one in these questions, but I definitely think it works better here. So let's get dy dv first. Dy dv is equal to, and it's based on our rules from up further, so I'll just write down the inverse sine of x over a goes to 1 over the square root of a squared minus x squared. So if v is in here, dy dv will go, because sine is the inverse sine of v, will go to 1 over the square root of, just to give it a fraction form, if I say v over 1, you can see that's where the 1 minus v squared, or 1 squared minus v squared, would come from. So that's dy dv. Let's look at dv dx. Now v is equal to 1 over x squared, which is equal to x to the power of minus 2. So dv dx is minus twice x to the power of minus 3, which is equal to minus 2 over x cubed. So now we're going to have dy dv, just change my v into 1 over x squared. So we're going to have 1 over the square root of 1 minus 1 over x squared to be squared. And that's going to give me 1 over the square root of 1 minus 1 squared over x squared to be squared is 1 over x to the power of 4. Where is this going? So we're going to bring this one down. So let's look at dy dx now. I'll do it here. Dy dx is equal to, I'll write it out again, dy dv by dv dx, which in this case, dy dv is equal to 1 over the square root of 1 minus 1 over x to the power of 4. Now I might make that a single fraction now. I think that'll help us. And that's going to be times 2 over x cubed. So let's make the one on the left here a single fraction. So we're going to get 1 over the square root of, if they're both fractions, we're going to get x to the power of 4 minus 1 over x to the power of 4. Now this will help, because now I can separate this into 2 square roots. And I'll be able to get the square root of x to the power of minus 4. And I think I left out my minus here, times minus 2 over x cubed. So this fraction will be 1 over the square root of x to the power of 4 minus 1 on top over the square root of x to the power of 4 on the bottom. I'm still multiplying by minus 2 over x cubed. And I can see here now, I can separate it. I'm going to get minus 2 on top. And the square root of x to the power of 4 is equal to x to the power of 2. So I would have the square root of x to the power of 4 minus 1 by x cubed over x to the power of 2. And then that will simplify just to be x. So it's going to be equal to minus 2 over x times the square root of x to the power of 4 minus 1. So practice some of these inverse trigonometric functions from the book. And in the next video, we'll look at some of the solutions to the exercises in 13.7 if you're using active maths.